Ever wonder how to write more concise, powerful, and Pythonic code, especially when dealing with data transformations? Today, we're diving deep into Lambda functions, map, filter, and reduce, the cornerstones of functional programming in Python. By the end of this tutorial, you'll be writing elegant, efficient code like a true Python expert. Before we jump in, a quick reminder. Our Discord community is buzzing with developers just like you. It's the perfect place to get help, collaborate on projects, and even practice your soft skills with team challenges. Join us, the link is in the description. Let's kick things off with Lambda functions. At its core, a Lambda is simply a small, anonymous function. Think of it as a function without a name, defined in a single, concise expression. It's perfect for quick, throwaway functions you'll use only once. The syntax is straightforward. Lambda arguments, expression. Notice the crucial limitation. It must be a single expression. No loops, no multi-line statements here. This keeps them lean and focused. Let's see a basic example. Here we define a lambda to double a number, then immediately call it. It's quick, but often lambdas shine when passed to other functions. This brings us to map. The map function applies a given function to every item in an iterable, like a list, and returns an iterator of the results. It's a powerful way to transform entire sequences of data. Let's map our double lambda over a list of numbers. See how concisely it transforms each element. We convert the map object to a list to see the results. Next up is filter. As the name suggests, filter constructs an iterator from elements of an iterable for which a function returns true. The function you provide acts as a predicate, deciding which elements make the cut. Here, we'll filter out only the even numbers from our list using a lambda. Notice how the lambda concisely defines our filtering condition. Now we move into the powerful reduce function, which, unlike map and filter that return iterables, reduces an iterable to a single cumulative value. You'll need to import it from functools. Let's calculate the sum of our numbers using reduce. The lambda here defines the accumulation logic. A tricky technique is understanding the optional initializer. If provided, it's the starting value. Otherwise, reduce starts with the first two elements. For an empty list, initializer becomes the result, preventing errors. This is where advanced Python truly shines, knowing when to choose the right tool. While map and filter are powerful, Python's comprehensions, list, dictionary, and set often provide a more readable Pythonic alternative for simple transformations and filtering. Let's compare side by side. So, when do you use map filter versus comprehensions? Generally, comprehensions are preferred for simple, direct transformations and filtering due to their readability. Map and filter are excellent when you already have a named function, or when you're building functional pipelines that involve more complex chained operations without immediate list creation. They also produce iterators, which can be more memory efficient for very large data sets. Here's an expert-level feature, using Lambda to create closures. A closure is a function that remembers values from its enclosing scope, even after that scope has finished executing. We can create a higher-order Lambda that returns another Lambda, effectively customizing behavior dynamically. Now let's build an advanced functional pipeline. We'll combine map and filter to first filter out odd numbers, then square the remaining even numbers. This demonstrates chaining operations elegantly. A classic tricky technique is using Lambda with the key parameter in sorting functions like sorted or list.sort. This allows you to sort complex data structures like lists of tuples or objects, based on a specific element or a computed value. Here, we'll sort a list of names by their last name. What makes all this possible in Python is that functions are first-class citizens. This means you can treat functions like any other variable, assign them to names, pass them as arguments to other functions, and even return them from other functions. This is the foundation of functional programming in Python. Functional programming often emphasizes immutability and pure functions, functions without side effects. While map, filter, and reduce themselves don't inherently enforce this, they promote a style where data transformations produce new data rather than modifying existing structures in place. This can lead to more predictable and testable code, reducing subtle bugs. Finally, a word on readability. While Lambda, map, filter, and reduce can make code extremely concise, remember that excessive nesting or overly complex lambdas can hinder readability. Always balance conciseness with clarity for future maintenance. Pythonic code values explicit over implicit. Ready to solidify your understanding? Head over to our Discord. There, you'll find an auto-assessment quiz, real-world coding challenges, and the complete GitHub repository with all the code from this tutorial. It's the perfect way to practice and integrate these advanced concepts. Today, we unlocked the power of functional programming in Python with Lambda functions, map, filter, and reduce. You learn to create anonymous functions, transform and filter data efficiently, and reduce iterables to single values. We also explored when to use these tools versus comprehensions, tackled advanced concepts like closures and custom sorting, and discussed best practices for readability. If you enjoyed this Python Masterclass, don't forget to like this video, subscribe to the channel, and comment below what you want to learn next. Our next lesson is list comprehensions and generators.